So hi guys, now we are going to see the answer for the antennas and other concepts quiz questions, part 3. Okay, so antenna radiation pattern shows what? Okay, it will show main lobe and side lobe only, not impedance matching. But that is reflection coefficient or return loss S parameter only will show impedance. VSWR parameter plot only will show impedance matching. This is straightforward answer. Next is which is more efficient in millimeter wave frequencies, which is spot beam, okay, not broad beam, okay. So broad beam means again it will be a loss, okay, huge loss will be there. The spot beam concept not only coming from straight away from not just came to 5G directly, it has come from satellite communication, so the idea was already have been used by satellite communication in I think more than 2 decades. They have been using this spot beam concept because in order to cover only a particular region, so to avoid the waste of courage or waste of power or waste of money, so they have been using. Next is which polarization. So what I was telling that spot beam concept is not new. Okay, it has been using for especially for millimeter wave. It is a very good concept. That's why in 5G they are going for beam forming concept or spot beam. Okay. Next is which polarization can be used to receive the signals from any direction. Obviously circular polarized, because when you are keeping your antenna linearly polarized, and then if you are, for example, when you are keeping your antenna for example linearly polarized, then your signal is horizontally polarized, then you will not get the signal properly, because you will get a 3 dB loss. Okay, already a minimal signal, so you will not get exactly. So that's why most of the satellite communication, most of the reception radio station, receivers station will have a circularly polarized antenna, because the problem is that so when the signal come from satellite transponder to the ground station, what happens is it is passing through several ionosphere, troposphere, stratosphere. So many layers it is crossing. So what happens is there polarization twist will happen. So that polarization it will get diffracted. So due to that polarization twist will happen. So linearly polarized signal may twist to higher horizontally polarized, not slant polarized. So many form, it can be a many form also. So it cannot be a purely purely either vertical or horizontal. Okay, it can change its form of polarization. So that's why we always use circularly polarized antenna. So that it can receive any polarized signal. So this is the concept. Okay, and the main problem with the circular polarization is that achieving wide bandwidth is very difficult. Means that has been still open challenge, open area that researchers are, most of them are concentrating. Next, anechoic chamber measurement is an indoor measurement, not an open measurement. So for making it indoor only, we are going for anechoic chamber, because open area has several limitations, weather conditions and multipath fading. So several limitations are there. That's why we are going for indoor measurement done by anechoic chamber. Next is both near field, type of near field measurements are direct far field and indirect far field. Okay. So direct far field is nothing but direct far field is nothing but using Cantor chamber. Okay, compact antenna test range. We can use direct far field. We can achieve direct far field. Indirect far field means we use probes to measure the antenna fields at the near field. Then we will take FFT and compute the far field. That is why it is called as indirect far field. Okay, from near field to far field, transformation will happen. So once you capture the field quantities, we have to transform the near field quantities to radiation pattern. That's it. Next is which measurement technique is used for direct far field measurement, which is direct far field measurement technique is used for direct far field measurement. So it's not a it's a vague question only, because technique. So that's why I used okay, it is nothing but your compact antenna test range. So okay, so far field is measurement is a method. So it is a somewhat typical question. Okay, so the specific method that we use direct far field measurement is compact antenna test range. Okay, So conventional far field, anyway it is there. So we have to keep our antenna at receiver antenna at DUT antenna at a far field distance. But at shorter distance, direct far field measurement are done in context to previous one. So because near field measurements, that in context to previous question when I have posted this question. So used for direct far field measurement is compact antenna test range. It is not a planar near field or spherical near field, because here the transformation is needed. But far field measurement is a conventional measurement method. Okay, that's why the answer is compact antenna test range. Next is beam forming. Beam forming can be achieved by modifying. It should be excitation, amplitude and phase. Okay, you can achieve only by amplitude or phase. Okay, but so you cannot achieve beyond certain limits. So that's why we go for both, excitation, amplitude and phase will be modified to achieve beam forming. Okay, the gain is a product of what? So obviously it is directivity and efficiency. So that is why the gain and directivity are both are same if efficiency is 1, which means there is no loss at all for no lossy medium. So the directivity and gain are same. Okay, so when you employ lossy medium only, the efficiency come into picture because so many losses are accounted. So that's why you are having another parameter called gain. So gain is gain in direct efficiency multiplied by directivity. That's why the answer is A and B. So thank you guys. Keep watching. Please subscribe. Thank you.